Chapter 15, Static Electricity, Part 1. Okay, in this first part, we are going to cover 15.1, which is what are electric charges, as well as what is an electric field. Okay, so these are the learning outcomes. Okay, this one is about electricity and lightning. We come across a lot of electricity and lightning around the world. Okay, in this chapter, we will study how does lightning occurs, okay, what is the reasons for lightning, etc. So in general, electrostatics is the study of non-moving electric charges. That's why it's called static. Static is non-moving, static electricity. Okay, and then after this chapter, we'll be moving on into moving charges, which is actually which actually results in a current. So non-moving charges are called static electricity, while moving charges will result in a current. Okay, so let's move on into the first part. What are electric charges? This is actually a bit of recap from your chemistry. Okay, you need to know that all metals are made out of atoms, and inside an atoms, there are charges. So everything has charges inside them. So where are the charges? You should be very familiar with it. You have protons and neutrons inside the nucleus. Okay, so which one is charged? Is the proton that is being charged, positive charge. And around the atom, you have electron shells where you have electrons on it, and the electrons are negatively charged. So in every substance, there is atoms, and in every atoms, there is positive charge caused by your protons and negative charge caused by your electrons. Okay, and you should know that atoms itself contains equal number of protons and neutrons. So they have equal number of positive and negative charge, and they are neutral. Okay, in physics, we will zoom on into what are these charges. Okay, so electric charge, the SI unit for the charge is actually called coulombs. Okay, it's discovered by this Coulomb's scientist. So that's why the SI unit for electric charge is coulomb. Okay, it's represented by the letter big C. Okay, and each electrons or protons have the same amount of charge, which is this 1.6 times 10 to the power minus 19 coulombs. Okay, for electrons, it will be negative 1.6 times 10 to the power minus 19. And for protons, it will be positive 1.6 times 10 to the power minus 19 coulombs. Okay, and you should also know this, whenever atoms loses electrons, we say that it becomes positively charged. And when it gains electrons, we say that it becomes negatively charged. So in this case, we don't talk about atoms, we just talk about objects. When we say that an object is neutral or uncharged, it doesn't mean that it has no charge at all. It simply means that the number of positive and the number of negative charges are equal. If I'm positively charged, it means that I have lesser electrons. I have more positive charge than negative charge. If I'm negatively charged, it simply means that I have more negative charges than the positive charge. Okay, so, and you need to know some of the basic laws of charges. Okay, the basic laws of charges are very easy. Like charges repels, unlike charges attracts. That's it. Okay, so now you may pause the video to think about this yourself. I have two spheres, sphere 1 and sphere 2, and then this is the charge on each sphere, whether they attract or repel. You should know the law of charges. The first one, like charges, plus, plus, they will repel. Okay, the second one, unlike charges, plus, minus, they will attract. Third one, plus, minus again, attracts. And the last one, minus, minus, is again like charges, they will repel. Okay, next, we move on into electric field. So the first part is just every atom have got charges, or every object has got charges caused by the protons and electrons. When I have more plus, I become positively charged. When I have more minus, I become negatively charged. And when I'm neutral, I just have equal number of plus and minus. Okay, the second part about electric field. Okay, you need to know the definition of an electric field, which is given by this yellow box. Okay, an electric field is a region whereby an electric charge experience an electric force. So you put anything that's charged there, it will experience an electric force. Okay, so recap a little bit again, you need to know the different fields. Okay, so far you have currently learned about gravitational field. So all of them are regions. So gravitational field is a region where a mass experiences a gravitational force. Electric field is a region where an electric charge experiences an electric force. Later on, you will be learning about magnetic fields as well. So magnetic field is again a region where a magnetic material experiences a magnetic force. So the definitions are all very similar. Okay, so you need to memorize it because they tend to ask for the definition of electric field. Okay, next, an electric field, how do we illustrate it? We can't really see an electric field, but in science, we always use models to try to represent how does an electric field look like. So we usually illustrate electric fields with lines and then again arrows to show the direction of the electric field. So the direction of an electric field is always defined as how would a small positive charge move. Okay, so electric field lines looks like this. Electric field lines is used to represent electric field. Okay, we always take the guiding principle that is the path that a positive charge will move. So if I have a negative charge over here, then my positive charge will all like to move towards it because unlike charges attracts. So my positive charge will all want to move towards the negative charge. So electric field lines is always pointing towards a negative charge and away from a positive charge. So if I have a single charge, it's always in a radical direction, like the sun rays. Okay, if I'm negative charge, all point towards me. If I'm positive charge, all points away from me, because if I'm a positive charge, I will want to repel away from a positive area. Okay, and the next thing that you need to know is the strength of the electric field is determined by how close the field lines are to one another. So when it's nearer to the charge, the field lines are closer. The further away from the charge, okay, the lines spread out even more. So if the lines are very close together, it simply indicates that the electric field is very strong. And if it's far away, it means that the electric field is very weak. And just take note, whenever you're drawing, you need to use ruler to draw, and they cannot cross each other. There should be no field lines that cross each other. Okay, it's good practice to get this correct at the first time, because later on you will also need to draw for magnetic fields. Okay, you also need to use lines to represent magnetic field lines, and the concepts is very similar. Okay, so I give you more examples of how electric field lines looks like for two charges together, or electric plates as well. Okay, just now it's a single charge, so a single charge is like the sun ray. Okay, when you're two charges, it looks like this. Obviously, you don't need to draw so many. Okay, you can just draw 3 from the plus and 3 from the minus. Okay, so when you have a plus and a minus, there will be an attractive force. Okay, so you will have arrows from the plus away from plus towards minus. So it looks like this, and then at the side, it will be curved. Okay, and then when you have two positive charge, it will be repelling each other. So your electric field lines looks like this. In the center over here, there is no electric field lines, means there's no electric field. Okay, they will repel each other such that in the center part, there is no field at all. You put a charge here, it will not experience any force because there's no electric field. Okay, then for a plate, okay, it will look like this. Okay, at the center, it will be all uniform, so they will all be equally spaced. And then at the side, it will be a curve, slight curve for electric plates. Okay, next, let's do a small little practice. You may pause the video at this point to think about the answers. Here, I'm going to go through. Number 1, a small hidden metal sphere has an electric field around it, and a portion of the field is represented here. What is the type of charge on the sphere? So there is a sphere here, and this is the electric field here. So you can see that the arrows are all pointing towards this sphere, okay? Because I know that it must be on the right side and not on the left side, because the field lines are closer here. The field is stronger when it's closer to the charged object. So the charged object must be on this right side over here. So I'm moving towards my sphere, so my sphere must be a negative charge because the electric field is towards it. So part D, draw a small circle to indicate the position of the charge. So the position of the charge should be here, minus. Okay, so all my electric field lines should be going towards the negative charge. And then in this portion of the field shown, is the field strength stronger on the left or on the right? Okay, it will be stronger on the right side because the field lines are closer. This side, the field lines are closer as compared to the left side. So the answer is as follows. Next one, given that an electron has a charge of 1.6 times 10 to the power 19 coulomb, how many electrons are there in 1 coulomb of charge? Okay, so 1 electron has this amount of charge. So 1 coulomb of charge will be how much? The answer is just 1 coulomb divided by 1.6 times 10 to the power minus 19. So in 1 coulomb of charge, there's actually this quantity, 6.25 times 10 to the power 18 electrons. Okay, but you don't need to memorize this. Okay, you may scan the QR code to work on some practice or to see how does the electric field lines looks like for different charges. Okay, so summary, the first part, neutral atoms all contains equal number of plus and minus. SI unit for charge is coulomb, big C. Like charges repels while unlike charges attracts. Electric field is a region where electric charge experience an electric force. That's all.